Earth, our blue planet, is covered by oceans across more than 70% of its surface. Yet beneath that breathtaking beauty lie some of the harshest and most dangerous waters ever known. Today, we journey into places where even nature itself seems unwilling to forgive mistakes. From storms that tear apart the sky to icy waters capable of freezing steel ships. From earthquakes shaking the ocean floor to the razor-sharp teeth of predators hidden in darkness. The ocean is not our enemy, but it has never been an easy friend. Six seas, 6 different levels of danger. Each possesses its own form of destruction, from ice and fire to deadly predators. This journey will take us through each of them and reveal why humanity remains only a small visitor upon the vast ocean. For thousands of years, sailors have shared stories capable of chilling the blood. Ships vanished without a trace. Expeditions disappeared forever. And the ocean, offering neither explanation nor apology, silently swallowed them all. But this is not only a story of destruction. It is also a story of power, wonder, and the lessons the ocean offers humanity. Listen closely, because the ocean is speaking, and its voice is impossible to ignore. The Southern Ocean surrounds Antarctica, the coldest continent on Earth. No landmass blocks the winds, and no barriers weaken the enormous waves. Here, nature operates with its full, untamed power. Storms here are known by fearsome names such as the Roaring Forties, Furious Fifties, and Screaming Sixties. They are named after the latitudes where winds howl endlessly across the ocean. Often exceeding 120 kilometers per hour, these winds transform the sea into a white inferno. Waves in the Southern Ocean can reach heights of 25 meters, as tall as an 8-story building. With no land for thousands of kilometers to weaken them, they continue gathering energy as they circle Antarctica endlessly. Maritime history records hundreds of shipwrecks in these waters. Even steel vessels have been twisted and crushed by the combined force of wind and sea. The Southern Ocean makes no distinction between wooden ships and iron ones. All are vulnerable to its power. Beyond waves and wind, giant icebergs represent another deadly threat. Only a small fraction is visible above the surface, while the massive bulk remains hidden below. In thick fog, spotting them can become nearly impossible. Remarkably, life thrives even in such extreme conditions. Giant albatrosses travel thousands of kilometers without rest, while penguins dive into icy waters in search of food. It is a powerful reminder of nature's ability to adapt and survive. The Southern Ocean is not only dangerous but also essential to the health of our planet. It absorbs vast amounts of human-generated carbon dioxide and helps regulate the global climate. If this system weakens, the consequences will be felt worldwide. In the Antarctic night, green and violet auroras dance across the dark ocean surface. Their beauty is so mesmerizing that it can make people forget the deadly conditions surrounding them. The Southern Ocean is a place where beauty and danger exist side by side. The Drake Passage is a narrow corridor connecting the Atlantic and Pacific Oceans at the edge of Antarctica. Though only about 800 kilometers wide, it concentrates much of the Southern Ocean's immense power. Sailors have long called it the mouth of hell, and that reputation was not earned through exaggeration. Waves in the Drake Passage can reach heights of 12 meters and may appear with little warning. Rapid atmospheric pressure changes make weather forecasting extremely challenging. For centuries, these waters have claimed countless lives and sent numerous ships to the bottom of the sea. Beneath Drake's icy waters lies a graveyard of ships that once challenged the sea. Hundreds of wrecks rest across the seabed, now serving as habitats for marine life. Each wreck represents an unfinished chapter of history and a story that may never be fully told. Beyond its waves and winds, the Drake Passage lies within a geologically active region. Earthquakes frequently occur beneath the seafloor, occasionally causing significant disturbances in the marine environment. Hidden volcanoes operate silently beneath the deep waters, reminding us that Earth's power is always present below the surface. Despite its fearsome reputation, Drake continues to attract those willing to face its challenges. Explorers, solo sailors, and scientific expeditions still cross these waters on their journeys to Antarctica. They are not fearless, but they believe some goals are worth the risk. Veteran sailors sometimes refer to rare calm days as Drake Lake, when the sea becomes smooth and peaceful. Yet that tranquility is only temporary. Even in its quietest moments, Drake holds the potential for its next outburst of fury. Off the coasts of South Africa, Australia, and California lives one of the ocean's most formidable predators. The great white shark stands at the top of the marine food chain, refined through millions of years of evolution. With immense size, remarkable speed, and highly developed senses, it is a master hunter of the sea. South Africa's Dire Island is considered one of the world's great white shark capitals. Each year, these giant predators gather there to hunt seals. They are famous for launching themselves from the depths and sometimes bursting completely out of the water in spectacular attacks. The hunting strategy of the great white shark is an evolutionary masterpiece. It approaches from the dark waters below, where sunlight conceals its silhouette from prey. When the moment arrives, the attack happens so quickly that the victim rarely has time to react. Dozens of shark attacks are recorded worldwide each year. Many are believed to result from mistaken identity, with sharks confusing humans for their usual prey. Yet, given the tremendous power of these predators, even a single bite can have devastating consequences. Ironically, great white sharks themselves are now threatened by human activity. Overfishing, ocean pollution, and declining food sources are placing immense pressure on their populations. A species that survived countless upheavals throughout Earth's history now faces one of its greatest challenges from humanity itself. Looking into the dark eyes of a great white shark, many see only fear and danger. Yet these animals are not monsters. They are an essential part of the marine ecosystem. Perhaps the more important question is not whether we should fear sharks, but what would happen to the ocean if sharks disappeared. The Atlantic Ocean is the second largest ocean on Earth and the birthplace of some of the planet's most powerful storms. Every year, from June to November, warm ocean waters fuel massive atmospheric engines. A single superstorm can release an astonishing amount of energy beyond human imagination. Storms such as Katrina, Sandy, and Dorian have left lasting scars on modern history. Storm surges can flood entire coastal cities within hours. Far offshore, gigantic waves sweep across vessels with overwhelming force. During winter, the North Atlantic becomes one of the harshest marine environments on Earth. Near-freezing water temperatures make survival extremely difficult. Powerful winds, towering waves, and ice accumulation create a relentless challenge for sailors. The Strait of Gibraltar is the narrow gateway connecting the Atlantic Ocean and the Mediterranean Sea. Opposing currents meet here, creating complex and unpredictable water movements. Throughout history, it has remained one of the world's most challenging maritime routes. The North Atlantic was the site of one of history's most famous maritime disasters. In 1912, the Titanic struck an iceberg and sank into the freezing ocean. More than a century later, the tragedy remains a symbol of humanity's vulnerability before nature. No discussion of the Atlantic is complete without mentioning the Bermuda Triangle. Stories of missing ships and aircraft have turned it into one of the world's most famous mysteries. Although science offers many explanations, the region continues to capture human imagination. After a storm passes, the Atlantic often returns to a remarkable calm. The sea becomes smooth, and the air feels freshly cleansed. It is a reminder that nature is neither good nor evil. It simply follows its own laws. Encircling the Pacific Ocean is a vast geological arc known as the Ring of Fire. It contains most of the Earth's active volcanoes and earthquakes. This region represents one of the greatest concentrations of geological power on the planet. When molten lava meets cold seawater, a violent reaction occurs instantly. Steam, gases, and chemical compounds are released into the atmosphere. Yet from these destructive processes, entirely new land can eventually emerge. Japan sits atop one of the most geologically active regions in the world. The 2011 earthquake and tsunami revealed the immense power hidden beneath the seafloor. Within a short time, entire coastal communities were changed forever. Beneath the Pacific lies a hidden world largely unseen by humanity. Thousands of underwater volcanoes remain active in the deep darkness. Although most of this activity goes unnoticed, it continues to shape our planet every day. Indonesia sits at the intersection of major tectonic plates, making it one of the most volcanically active nations on Earth. Historic eruptions have influenced not only local regions but also global climate patterns. It is a powerful example of how interconnected Earth's natural systems truly are. The Pacific is home to the deepest known place on Earth, the Mariana Trench. Its immense depth creates pressures far beyond the limits of most conventional equipment. It remains one of the most mysterious environments humanity has ever explored. Even in total darkness and crushing pressure, life continues to exist. Strange creatures have evolved remarkable adaptations to survive in these extreme conditions. They demonstrate that life can flourish in places once thought impossible. The Philippines is one of the most storm-affected nations on Earth. Numerous powerful typhoons have caused tremendous human and economic losses. Yet its people continue to adapt, rebuild, and move forward after every disaster. New Zealand sits on the boundary of major tectonic plates, making earthquakes a familiar part of life. These geological forces have created breathtaking landscapes of volcanoes, valleys, and coastlines. It is a place where natural beauty and natural power exist side by side. If the Southern Ocean is the realm of storms and waves, the Arctic Ocean is the realm of ice and cold. It may be the smallest ocean on Earth, but it hosts some of the harshest conditions on the planet. During winter, temperatures can plunge below -40 degrees Celsius, cold enough for the air itself to feel like a blade against exposed skin. Arctic icebergs can grow to the size of entire cities. When they crack apart or overturn, they release tremendous energy capable of generating powerful local waves. The sound of breaking ice echoes like thunder, traveling for dozens of kilometers across the polar night. Ships crossing the Arctic Ocean are often escorted by specialized icebreakers. Yet even these powerful vessels can become trapped within shifting sea ice. Cracks may open and close rapidly, creating enough pressure to crush a ship's hull in a surprisingly short time. Polar bears are the iconic predators of the Arctic and among the most formidable hunters in the region. Perfectly adapted to life in extreme cold, they stand at the top of the Arctic food chain. Yet even these powerful animals are losing their habitat as sea ice continues to shrink. Climate change is transforming the Arctic Ocean faster than almost anywhere else on Earth. As ice retreats, new shipping routes emerge and access to natural resources expands. However, these changes also bring environmental consequences that scientists are still working to fully understand. During summer, the Arctic experiences the midnight sun, when daylight lasts for weeks without interruption. Golden light stretches across the ice and sea, creating a scene of almost unreal beauty. Yet beneath that beauty lies a fragile ecosystem facing increasing pressure from global warming. Scientists working in the Arctic face extreme conditions every day. They study sea ice, climate systems, and ecosystems to better understand the changes taking place. The data they collect helps reveal not only the future of the Arctic, but also the future of our planet as a whole. Six oceans, 6 lessons about the power of nature. The Southern Ocean teaches resilience, Drake teaches courage, and great white sharks reveal the importance of ecological balance. The Atlantic reminds us of humility, the Ring of Fire of fragility, and the Arctic Ocean of our responsibility toward the future. The ocean is not an enemy to conquer, but a teacher to listen to and respect. Humanity cannot control nature, but it can choose to live in harmony with it. Protect the oceans, for they are the beating heart of our planet, and that heart needs our care now more than ever. From space, Earth appears almost like a water world. A single ocean covers nearly half of the planet's surface. This is the Pacific Ocean, the largest and deepest ocean ever known to humankind. The Pacific Ocean is larger than all the continents combined. From Asia to the Americas spans over 20,000 kilometers, a distance nearly enough to circle the Earth. Nothing on this planet compares to its scale. It is called Pacific, meaning peaceful, but that name only reflects the surface. Beneath this calm lies a world of intensity, chaos, and mystery far beyond human understanding. Most of the Pacific remains unexplored. We know more about the surface of the moon than the depths of this ocean. This is Earth's true final frontier, not outer space, but the ocean beneath our feet. The Pacific is not just water. It is a vast living system, regulating climate, sustaining billions of lives, generating storms, and shaping human history. The journey to understand it begins here. The Pacific is far from calm. Beneath the seafloor, massive tectonic plates are constantly shifting, colliding, and sinking beneath one another. This is the largest geological engine on Earth, operating for hundreds of millions of years. The Pacific seafloor is as complex as any land surface. Vast underwater mountain ranges stretch for thousands of kilometers. Deep, silent plains extend endlessly, and dark trenches carve deep into the earth, all hidden beneath kilometers of water. The Ring of Fire surrounding the Pacific contains about 75% of the world's active volcanoes. It is also responsible for over 90% of major earthquakes. Nowhere else on Earth is geological activity this intense and dangerous. Hundreds of volcanoes are actively erupting beneath the Pacific right now. They release molten lava, create new islands, and reshape the ocean floor over time. Fire and water coexist in a dance that has lasted for millions of years. The Mariana Trench is the deepest point on Earth, reaching nearly 11,000 meters. If Mount Everest were placed inside it, its peak would still lie more than 2 kilometers below the surface. The pressure can crush steel, yet life still exists there. Only a handful of humans have reached the bottom of the Mariana Trench, fewer than those who have walked on the moon. Each mission is a journey into the most extreme conditions life and technology can endure. This is the most alien place on our own planet. When tectonic plates shift suddenly, centuries of stored energy are released in an instant. Tsunamis form, traveling at jet-like speeds and carrying the force of millions of tons of water. The Pacific is the origin of most of the deadliest tsunamis in history. All life in the Pacific begins with organisms too small to be seen. Phytoplankton, microscopic algae, perform photosynthesis and produce more than half of the oxygen we breathe. If they disappeared, the entire ocean ecosystem would collapse within weeks. The next step in the food chain is zooplankton, tiny drifting creatures that feed on phytoplankton. Each night, they perform the largest vertical migration on Earth, rising to feed, then descending to avoid predators. This is the hidden heartbeat of the ocean. Millions of small fish gather into massive schools for protection. This is one of nature's most spectacular phenomena. Millions of individuals moving as a single organism, confusing predators through perfect synchronization. Higher in the food chain are high-speed predators like tuna and swordfish. They can reach speeds of up to 80 kilometers per hour in water, faster than many land animals. Evolution has shaped them into perfect hunting machines over millions of years. Sharks are the regulators of the ocean. For over 450 million years, they have sat at the top of the food chain, controlling populations below. When sharks disappear, rays explode in number, destroying seagrass, triggering unpredictable domino effects. The blue whale is the largest animal ever to exist on Earth, heavier than 20 elephants. Yet this giant survives by feeding on tiny krill. It is nature's greatest lesson. Everything is connected, and the greatest power depends on the smallest life forms. Orcas are the wolves of the sea, hunting in groups, possessing their own language and passing down culture through generations. They even teach their young hunting techniques over years. Their intelligence raises a question. Where is the line between instinct and culture in the ocean? At a depth of 200 meters, sunlight can no longer reach. Beyond this point begins another world, one without light, without seasons, and with temperatures hovering around 2 degrees Celsius year-round. This is the twilight zone, the boundary between the familiar world and a completely alien one. Darkness does not mean the absence of color. The deep ocean is filled with bioluminescence. Hundreds of species create their own light to hunt, communicate, or defend themselves. It is the most extraordinary light show in the universe, happening every night, unseen. Deep-sea creatures seem designed by an entirely different imagination. Transparent jellyfish stretch longer than whales, vampire squids drift with webbed arms, and red tube worms grow like forests. The deep ocean hosts a biodiversity unlike anything on land. At hydrothermal vents, superheated water at 400 degrees Celsius erupts from the ocean floor. There is no sunlight, no oxygen from photosynthesis, yet life thrives here. These organisms rely on chemical energy from sulfur, forming an ecosystem completely independent of the sun. Ecosystems at hydrothermal vents prove that life does not require sunlight to exist. This has implications beyond Earth. If life can survive in such darkness and pressure, it may also exist on ocean moons of Jupiter or Saturn, waiting to be discovered. The giant squid was a creature of legend for thousands of years, yet it was first filmed only in 2004. Weighing up to 300 kilograms and possessing the largest eyes in the animal kingdom, it is not myth, but reality. The deep sea still hides secrets like this. Every time a submersible reaches the ocean floor, new species are discovered. Scientists estimate that only about 20% of the seafloor has been mapped in detail. The remaining 80% is terra incognita, the unknown frontier of our own planet. In 1997, a U.S. underwater listening system detected a mysterious signal loud enough to be heard across the Pacific. It was named the bloop. No known organism is large enough to produce such a sound. Its true origin remains unanswered. The bloop was not alone. Julia sounds like a distant scream. Upsweep is a long rising tone lasting for hours. And slow down is a strange decelerating signal from an unknown source. The ocean has its own language, and we understand only a fraction of it. Point Nemo is the most remote location on Earth, over 2,600 kilometers from the nearest land in every direction. The closest humans are not on Earth, but aboard the International Space Station overhead. Parts of the Pacific are isolated beyond imagination. Point Nemo is also known as the spacecraft graveyard, where space agencies deliberately sink decommissioned spacecraft. It is remote enough to pose no danger to anyone. The Russian Mir station and parts of the ISS now rest on the ocean floor there. We have mapped 100% of the Moon and 98% of Mars, but only about 20% of Earth's ocean floor. In fact, we know more about Venus's surface than the Pacific seabed. Many of humanity's biggest answers may lie hidden in that darkness. Every ocean expedition is a battle against the limits of technology and nature. The deep sea does not forgive mistakes. Pressure, darkness, and total isolation push humans to the edge. Yet every discovery only leads to dozens of new questions. Since World War II, Global seafood production has increased fivefold thanks to technology. Modern fishing vessels can locate and capture entire schools of fish within hours. Over 90% of large fish populations have disappeared in the past 50 years. An ecological collapse unfolding before our eyes. A temperature rise of just 1 to 2 degrees Celsius is enough to kill coral, the foundation of ecosystems that support 25% of marine fish. The Great Barrier Reef has lost over 50% of its area in just a few decades. Once gone, it can take thousands of years to recover. The Great Pacific Garbage Patch is twice the size of Texas and continues to grow every day. 8 million tons of plastic enter the ocean each year. Sea turtles mistake plastic bags for jellyfish, and whales die with kilograms of plastic in their stomachs. This is the cost nature is paying for human actions. Microplastics have infiltrated every level of the ocean food chain, from phytoplankton to blue whales. They are found in the salt we eat, the air we breathe, and even in human blood. The plastic we discard today will remain in the ocean for hundreds of years. The oceans absorb over 90% of excess heat from greenhouse effects. This is changing everything: ocean currents, fish spawning seasons, and species distribution. These changes are happening faster than any natural climate shift in the past 65 million years. Ocean currents like the AMOC, the Atlantic's climate regulator, are slowing due to freshwater from melting ice diluting ocean salinity. If they stop, northwestern Europe could cool by 5 to 10 degrees Celsius within decades. This is not science fiction. It is a real risk scientists are monitoring daily. Hundreds of millions of people depend on the Pacific for survival. Small island communities are losing fish stocks and land due to rising sea levels. For them, climate change is not statistics. It is the loss of ancestry, identity, and home. The Pacific Ocean is the planet's largest storm generator. Each year, dozens of tropical storms form across its surface, carrying energy equivalent to thousands of atomic bombs. They shape the weather of Southeast Asia, East Asia, and the western coasts of the United States. El Niño and La Niña are the Pacific's global climate controls. When El Niño occurs, Australia faces drought, Peru floods, and Southeast Asia experiences extreme heat, all triggered by changes in ocean temperature in one region of the Pacific. This is the clearest proof of the ocean's power to regulate global climate. The Pacific absorbs billions of tons of CO2 each year through phytoplankton and kelp forests, acting as the planet's second lung. Without this function, the rate of climate change would double. The ocean is not just affected by climate, it actively slows its impact. The Pacific is the world's largest trade route. Over half of global goods pass through it each year. The phone you hold, the clothes you wear, the food you eat, all likely cross the Pacific at some point in their journey to you. For thousands of years, Polynesian navigators crossed the Pacific using only stars and ocean swells. They explored this vast ocean not with machines, but with inherited knowledge and deep respect for nature. It is a relationship the modern world is slowly losing. The Pacific existed millions of years before humans and will continue long after us. But the form it takes, whether it remains diverse, alive, and capable of sustaining billions, depends on the choices we make today. Hundreds of scientists are working day and night to monitor every change in the Pacific. They map the seafloor, collect samples, track species, and measure temperatures. Not out of curiosity alone, but because they know understanding is the first step toward preservation. Science is hope. The Pacific is not just an ocean. It is a living world, a vast system that keeps Earth habitable. Its mysteries exceed what we know, its power surpasses imagination, and its future now lies in our hands. Beneath the surface we see, there exists another world, larger than any continent, darker than any night humanity has ever known. This is the ocean, and these are the creatures that rule it. The ocean covers 71% of Earth's surface and more than 95% of all living space on the planet. Yet humanity has only touched the surface of its mystery. Below, colossal lives unfold in silence. Light disappears at a depth of 200 meters. Beyond that lies the kingdom of eternal darkness, where the largest creatures ever to live on this planet drift silently through centuries. They do not need to display their power. Every movement carries millions of years of evolution. They are living proof that nature, when left untouched, can achieve greatness beyond imagination. From the Arctic to Antarctica, from the Pacific Ocean to the Indian Ocean, their migrations draw an invisible map across the planet. No borders, no passports, only instinct and memory. These are the giants of the ocean. And their story begins here. The humpback whale, Megaptera novianglii, possesses the longest pectoral fins relative to body size in the animal kingdom. Reaching up to 16 meters in length and weighing 30 tons, it still moves through the water with astonishing grace. Why do they breach? No one truly knows. Perhaps to communicate, to remove parasites, or simply because they choose to. For a brief moment, 30 tons of living muscle rise completely out of the ocean, a sight so unreal that even witnesses struggle to believe it. They feed by charging into dense swarms of krill and small fish, swallowing enormous volumes of water before filtering it through baleen plates. A single feeding session can last for hours, consuming thousands of kilograms of food each day during the Arctic summer. But what truly makes humpback whales extraordinary is their song. The males sing continuously, for hours, sometimes days, producing complex melodies that can travel thousands of kilometers beneath the sea. Their songs evolve with every season and every year. New patterns spread through populations like musical trends, learned, transformed, and shared from one whale to another. It is a form of culture, a civilization hidden beneath the ocean. Every year, they undertake one of the longest migrations of any mammal on Earth, nearly 10,000 kilometers from nutrient-rich polar waters to warm tropical seas where new life begins. A journey without maps, guided only by instinct and memory. Calves are born underwater and immediately pushed to the surface by their mothers for their very first breath. For nearly a year, they drink up to 200 liters of milk every day, gaining hundreds of kilograms each month as they prepare for the long life ahead. In a place where most life cannot survive, beneath the drifting ice of the Arctic, the beluga whale has found its home. Their pure white color is no accident. It is evolution perfected, camouflage for a frozen world. They are called the canaries of the sea because they produce hundreds of different sounds, whistles, clicks, chirps, and pulsing calls. Unlike most whales, belugas can move their facial muscles, creating expressions that seem almost human. Every summer, thousands of belugas gather in river estuaries to molt, socialize, and reproduce. These are among the largest gatherings of marine mammals on Earth, a noisy celebration filled with layers of sound and communication. Climate change is shrinking their world. Ice melts faster, ships enter waters once defined by silence, and artificial noise drowns out their delicate acoustic conversations. The belugas are listening, and what they hear is a world changing too quickly. Nothing on Earth, not dinosaurs, not any creature ever discovered, has ever been larger than the blue whale. Reaching up to 33 meters in length and weighing 180 tons, its heart is as large as a car and can be heard beating from 3 kilometers away. The ocean's greatest paradox: the largest creature on Earth survives by feeding on some of the smallest. Every day, a blue whale consumes up to 4 tons of krill, tiny shrimp-like creatures no larger than a finger, to sustain its immense living body. The calls of the blue whale are the loudest sounds ever produced by a living creature, reaching up to 188 decibels. Louder than a jet engine. Their voices travel across thousands of kilometers of ocean, acoustic messages moving through a silent world beyond human hearing. During the 20th century, humans killed more than 360,000 blue whales. Creatures that once crossed the oceans in vast numbers were driven to the edge of extinction within only a few decades. It became one of the greatest massacres in natural history. Today, only around 10,000 to 25,000 remain. In the vast emptiness of the ocean, finding another of their kind to communicate with, to reproduce with, can sometimes become impossible. The loneliness of the blue whale is the loneliness of a species slowly losing its world. The bowhead whale possesses a skull so powerful it can break through 60 centimeters of solid ice from below. Unlike most whales, they do not migrate seasonally. They remain in the Arctic year-round, following the shifting ice in search of narrow openings to breathe. They are the longest-living mammals ever discovered, with some individuals confirmed to survive for more than 211 years. A bowhead whale born in 1820 may still be swimming through Arctic waters today, carrying within it the memory of 2 centuries of changing oceans. Scientists are now studying the secret behind their extraordinary longevity: unique genes that repair DNA, resist cancer, and slow the aging process. Perhaps from these ancient giants, humanity may one day learn something profound about life itself. The whale shark, Rhynchodon typus, is the largest fish on Earth, growing up to 12 meters long. Yet the word shark can be misleading. They are completely harmless. Their enormous mouths, stretching over 1.5 meters wide, exist only to filter plankton and tiny fish eggs from the sea. They gather in nutrient-rich waters, river mouths, and coral reefs during spawning seasons, creating magnificent encounters where humans can swim beside them without fear. It is one of the most extraordinary experiences the ocean allows us to witness. Much of the whale shark's life remains unknown. They can dive deeper than 1,800 meters and travel thousands of kilometers across the oceans. Where they reproduce, where their young are raised, humanity still has no answer. The sperm whale, Physeter macrocephalus, possesses a massive square-shaped head that makes up nearly 1/3 of its body length. Inside lies the spermaceti organ, an enormous acoustic structure that allows it to navigate with echolocation so precise it can detect objects within centimeters in total darkness. They dive deeper than 2,000 meters, where pressure is more than 200 times greater than at the surface, hunting giant squid in complete darkness. A single dive can last over 90 minutes. It is one of nature's greatest hunts, unfolding far beyond the reach of human eyes. Circular scars often mark the skin of sperm whales, evidence of battles fought against giant squid in the abyss. These colossal struggles unfold in absolute darkness, with no witnesses and no recordings, only scars left behind to tell the story. Sperm whales live in tightly bonded family groups led by females. When danger approaches, they form defensive circles around their calves, heads inward and tails outward, a survival strategy refined over millions of years. It is unity, family, and protection among giants. Sperm whales sleep unlike almost any other creature on Earth. They float vertically in the water, motionless in small groups, for 10 to 15 minutes at a time. Brief moments of deep silence in the endless ocean, rare peace for hunters that almost never stop moving. Orcas, often called killer whales, are the apex predators of the ocean. No creature beneath the waves can afford to ignore them. Yet the word killer barely captures who they truly are, highly intelligent beings with social lives as complex as those of primates. Orca hunting strategies differ between populations. Some specialize in salmon, others hunt massive whales, while some teach their young to intentionally beach themselves to catch seals. These skills are passed from generation to generation. This is culture in the truest sense of the word. Within an orca pod, the oldest female becomes the guide. Grandmother orcas, living up to 90 years, carry memories of ancient feeding grounds, safe migration routes, and seasons of scarce fish. Their knowledge is one of the pod's greatest treasures. Young orcas are raised and taught by both their mothers and the entire pod for many years. They learn the unique calls of their family group, distinct dialects that differ even between pods sharing the same waters. Orcas from the Pacific and Atlantic may not even understand one another. When looking into the eyes of an orca, many scientists describe the feeling that another intelligence is looking back. Orca brains contain highly developed regions linked to social emotion, structures even humans do not possess in the same way. What truly exists inside their minds, we still do not know. Dolphins choose joy. They do not ride the bow waves of ships to hunt. They do it because they enjoy the speed, the waves, the game itself. Joy is a real evolutionary force in this species, and watching them reminds us that life is not only about survival. Bottlenose dolphins call one another by name. Each individual develops a unique acoustic signature recognized by the rest of the pod and used to communicate directly. Once thought to exist only in humans, this discovery is transforming the way we understand animal language. Coordinated dolphin hunts require real-time communication and complex division of roles. One group blows bubbles to trap fish, another waits above to strike, while others guard the outer edges. This is deliberate cooperation and strategy, not simple instinct. Dolphins are among the few animals capable of passing the mirror test, recognizing their own reflection as a sign of self-awareness. They use tools, teach survival skills to their young, and show empathy toward injured companions. The line between us and them may be far thinner than we once believed. Ship strikes kill hundreds of large whales every year. Human shipping lanes now cut across migration routes followed for thousands of generations, and in these collisions, the whales are always the ones that lose. Ocean noise from commercial shipping, military sonar, and industrial activity is overwhelming the hearing of whales. In a world where sound is vision, language, and navigation, noise pollution means isolation, disorientation, and death. Climate change is transforming the oceans faster than almost any geological event in millions of years. Rising temperatures reduce krill populations, collapsing food chains from the bottom upward. Melting ice destroys habitats that species have adapted to over hundreds of thousands of years. Marine scientists devote their lives to listening to, tracking, and understanding these creatures. Every piece of data collected becomes another fragment of a much larger picture we still cannot fully see. Conservation begins with understanding, and understanding begins with respect. Humanity has walked on the moon, yet more than 80% of the ocean floor remains unexplored. The world beneath the waves is larger, stranger, and richer than anything we can imagine, and its inhabitants are still waiting for us to learn how to listen. They existed millions of years before us. They witnessed mass extinctions, ice ages, and drifting continents. They are the living memory of this planet, silent witnesses to everything Earth has endured. They do not need us. But we need them. Their presence reminds us that true beauty does not require attention to exist. That greatness does not always demand recognition. That there are things far greater than ourselves, and that this is something beautiful. The ocean is still here, silent at the surface, alive beneath. The giants are still swimming through darkness, across thousands of kilometers of cold water, through songs that echo all night unheard by human ears. Let them continue to swim. Let the ocean remain theirs. From space, Earth glows with the lights of human civilization. But behind those lights lies an invisible network, flows of energy that sustain the world. And all of it converges on a single, small point on the map. This is the Strait of Hormuz, a narrow stretch of water less than 50 kilometers wide at its narrowest point. Between Iran and the Arabian Peninsula, it is the only gateway from the Persian Gulf to the open ocean. Without it, much of the world's oil cannot reach its destination. Every day, around 20 million barrels of oil, about 20% of global supply, pass through these waters. This is not just a statistic. It fuels cars, planes, power plants, powers the lives of billions. On the surface, Hormuz appears calm and peaceful. Still waters, open skies. Yet beneath that calm lies the weight of the global economy flowing through it every hour. On the horizon, massive ships line up like floating buildings. Each one longer than 3 football fields, carrying hundreds of thousands of tons of crude oil. They arrive and depart endlessly, never stopping. Japan, South Korea, India, and China, the largest economies in Asia, all depend on oil passing through Hormuz. If the strait were to close for even a week, global supply chains would fall into immediate chaos. But Hormuz is more than data and maps. It is home to thousands of people, fishermen, traders, families who have lived along these shores for generations. For them, the sea is not a shipping route. It is life itself. Beneath the strait lies an entirely different world, coral, fish, and marine life that existed long before humans discovered oil. And they are still there, living in silence beneath the massive ships above. These massive oil tankers are known as VLCCs, very large crude carriers. A single vessel can carry up to 320,000 tons of crude oil, enough to power a city of millions for months. Navigating through Hormuz is far from simple. Shipping lanes are tightly controlled, each only about 3 kilometers wide. A small mistake in darkness or fog could lead to an unpredictable disaster. More than 17,000 ships pass through Hormuz each year, nearly 50 per day. In such a narrow space, managing traffic requires near-perfect coordination between nations. The risk of oil spills is ever present. When accidents happen, oil can spread across tens of square kilometers within hours. Ecosystems may take decades to recover. After every spill, people bear the consequences. Fishermen lose their livelihoods, cleanup crews work tirelessly, and marine life often has no chance of rescue. An invisible threat is underwater noise. Ship engines generate powerful sound, disrupting how dolphins and whales communicate and navigate. Beyond oil spills, ships emit large amounts of CO2 and sulfur. Global shipping accounts for about 2.5% of emissions, and Hormuz is one of the most concentrated points on Earth. Beyond economics, there is a geopolitical dimension. Hormuz is a zone of tension where multiple powers, including the United States, Iran, and Gulf nations, maintain military presence. Every diplomatic conflict carries real risks for maritime safety. Even a single news report about tension in Hormuz can move global oil prices. In 2019, attacks on tankers near the strait caused prices to spike within hours, affecting fuel costs worldwide. At night, Hormuz never sleeps. Ships glow like moving islands across the dark water, never stopping. Because the world's demand for energy never stops. But look beneath the surface. Near Hengam Island, not far from major oil shipping routes, an entirely different world exists. Colorful corals, parrotfish, butterfly fish, a vibrant reef thriving in one of the most strategic seas on Earth. Dolphins still swim freely here, a beautiful yet heartbreaking sight beside massive oil tankers. Unaware, they live in one of the most polluted and dangerous marine environments on the planet. Sea turtles still return here to nest on white sandy beaches. They have survived millions of years of evolution. But now, they must adapt to an ocean changing faster than ever before. Scientists are monitoring every rise in sea temperature. The Persian Gulf is already one of the hottest marine regions on Earth, and it continues to warm. Coral bleaching occurs when waters become too warm, causing corals to lose their color and slowly die. When corals disappear, entire ecosystems that depend on them collapse. Less visible than coral reefs, but equally important, are seagrass meadows, breeding grounds for hundreds of fish species. They absorb carbon more efficiently than forests, yet they are rapidly disappearing. Dugongs once thrived in these waters, feeding on seagrass. Today, their numbers have declined drastically. As seagrass disappears, so do they. Seabirds still return, but fish are becoming scarce. Nature adapts, but only within limits. Everything is connected. When plankton shifts, the entire food chain is affected, from small fish to humans. On one side, a scientist studying fragile ecosystems. On the other, a massive oil tanker. Two worlds, two priorities sharing the same sea. Ahmed has fished these waters for over 40 years. His hands are rough, his eyes trained on the horizon. He knows the sea like the back of his hand, its currents, its winds, its changing seasons. But the sea he knows is changing. Massive oil tankers create waves that can overturn small boats. Engine noise drives fish away. And sometimes, thin oil slicks drift across the surface, signs of incidents never reported. Fish catches have dropped significantly compared to 20 years ago. Fishermen must travel farther, stay longer at sea, and return with far less. Every evening, women and children wait on the shore for boats to return. The sea sustains them, but it can also take everything. Every journey is a gamble. The younger generation stands at a crossroads. Fishing no longer provides enough to support a family. Many have left the trade, seeking work in industrial zones or moving to cities. A centuries-old tradition is slowly fading. This is not the first time Ahmed has pulled up nets coated in oil. They must be cleaned for hours, sometimes thrown away. The loss is real, yet no one is held accountable. From above, the village appears almost invisible beside massive passing tankers. A stark image of imbalance between local communities and global energy systems. For fishermen, the sea is not a resource or a route. It is a relationship, a long-standing bond between people and nature. And that bond is slowly being broken. Imagine the global energy and trade network as a complex circulatory system. In that system, Hormuz is the valve where all flows must pass. If that valve shuts, the entire system stops. Thousands of kilometers away, trading floors in New York, London, and Singapore react instantly to events in Hormuz. Financial markets and this distant sea beat in the same rhythm. For Gulf nations such as Saudi Arabia, the UAE, Kuwait, and Iraq, Hormuz is a lifeline. It is the only route to export oil, the foundation of their entire economies. Alternative routes exist, such as pipelines across the desert. But their combined capacity handles only a fraction of the flow. There is no true replacement for Hormuz. This is why Hormuz is always present in international negotiations. Every energy agreement, every nuclear talk with Iran, every military arrangement carries its shadow. The question grows louder: can the world reduce its dependence on Hormuz? Renewable energy is rising, but oil still dominates. The transition is happening, but far slower than needed. A narrow stretch of sea carries the weight of modern civilization. It is both a triumph and a vulnerability of our world. This is the defining contradiction of our time. We need energy to build civilization, yet extracting and transporting it is slowly destroying the natural foundation we depend on. Nowhere is this more visible than in Hormuz. Three people, three perspectives on the same sea. A fisherman sees his livelihood fading. A scientist sees ecosystems declining. A ship captain sees an essential lifeline. All of them are right, and that is the problem. Sometimes, in rare moments, the sea returns to its natural state, quiet, vast, and free. No engines, no smoke. And in that silence, it feels like the ocean is trying to remind us of something. Hormuz is more than a place. It is a question of values, economic growth versus planetary sustainability. We may avoid the question, but we cannot escape its consequences. The sun sets over the Strait of Hormuz. Ships keep moving. The sea remains, sustaining the world while being pushed to its limits. The question is not whether we can protect the ocean, but whether we will choose to before it is too late. On the world map, there is a narrow strip of water less than 33 kilometers wide, so small it is easy to overlook. Yet every day, 30% of the world's oil passes through here. It is called the lifeline of civilization. Every day, around 21 million barrels of oil silently pass through here, carried by massive tankers longer than 3 football fields. They come from the oil fields of Arabia and travel to every corner of the world. There is no alternative route. The Strait of Hormuz lies between Iran and the Arabian Peninsula, a single gateway connecting the Persian Gulf to the Indian Ocean. Its full width is 33 kilometers, but the actual shipping lanes are only about 3 kilometers each way. It is one of the most closely monitored geographic spaces on Earth. Thousands of years ago, Arab traders sailed these waters, carrying spices, pearls, and silk to India. Hormuz was once an independent trading empire where sea routes converged. Its role has changed, but its importance has never diminished. The human body can survive weeks without food and days without water, but only minutes without breathing. The global economy is the same. It can endure many shocks, but it cannot survive if Hormuz is closed. That is why this place is called the throat of the world. "21 million barrels of oil. That is what the Strait of Hormuz must digest every single day. If poured into Olympic swimming pools, it would fill over 30,000 of them. No other oil transit route on Earth comes close to this scale. China is the world's largest oil importer, and much of it must pass through Hormuz. Every factory running, every car moving, every building being heated in China is tied to this narrow stretch of water. It is a geographic dependency Beijing has never been comfortable with. Japan imports over 90% of its oil through Hormuz. With no significant domestic energy and no pipeline alternatives, it relies entirely on tankers and a single strait. South Korea faces a similar reality. For both nations, Hormuz is not a choice, it is geographic destiny. If supply through Hormuz is disrupted for just a few days, global oil prices could surge by tens of percent within 24 hours. And when oil rises, everything rises: transport, manufacturing, food, electricity. The global supply chain tightens like a body cut off from its blood flow. We often think of oil as fuel for cars or planes. But it is also the foundation of plastics, fertilizers, pesticides, paints, synthetic fabrics, and thousands of other products. Half the items in the room you are in contain petroleum derivatives. Hormuz doesn't just carry fuel, it carries modern industry itself. India, one of the fastest-growing economies in the world, is also increasing its dependence on Gulf oil. The Jamnagar refinery processes over 1 million barrels a day, most of it arriving through Hormuz. The prosperity of hundreds of millions of Indians is anchored to a strait thousands of nautical miles from Mumbai. The northern shore of the strait belongs to Iran, the country that controls much of this strategic waterway. From here, every passing vessel is within sight, radar range, and if necessary, missile range of Tehran. It is one of the rare geographic advantages Iran holds in the global geopolitical game. Along Iran's coastline, anti-ship missiles like Noor and Khalij Fars are positioned on rugged mountain terrain. They can strike targets hundreds of kilometers away, and within the narrow confines of Hormuz, no vessel can escape their range. This is asymmetric warfare, low cost, high destructive impact. Iran does not rely only on exposed weapons. Inside coastal mountain ranges, underground bases carved into rock-house fast boats, missiles, and command centers. Satellite imagery cannot fully reveal them. Conventional bombs cannot easily penetrate them. This is a hidden card Iran holds, and its adversaries know it well. A $13 billion U.S. aircraft carrier can be overwhelmed by hundreds of small speedboats worth only tens of thousands each. This is the swarm tactic Iran has practiced for decades, attacking simultaneously from all directions with speed and overwhelming numbers. In the narrow waters of Hormuz, traditional technological superiority becomes ineffective. Beneath the strait, where no human eye can see, Iran could deploy thousands of naval mines within hours. A single mine can tear open the hull of a supertanker. And once a few ships are damaged or sunk, the entire route can be shut down, not by force but by fear. It is one of the most effective psychological weapons in Hormuz. In response, the United States Navy maintains a constant military presence in the Gulf and the Strait. The Fifth Fleet, based in Bahrain, patrols 24/7, with ships, radar, and satellites tracking every movement. It is a never-ending mutual surveillance, and both sides know a single mistake could trigger disaster. What sounds like a hypothesis has already happened multiple times. In 2019, several oil tankers were attacked near Hormuz, their hulls breached and crews thrown into panic. Oil prices spiked instantly, and global financial markets trembled. Just a few attacks without full-scale war were enough to trigger worldwide economic anxiety. In summer, temperatures in Hormuz can exceed 50 degrees Celsius. The sea becomes a mirror reflecting intense heat, and metal surfaces on ships can burn skin on contact. Crews work in conditions nearly beyond human tolerance, while electronic systems frequently fail under extreme temperatures. From the Arabian Desert, massive sandstorms regularly sweep into the strait, reducing visibility from kilometers to zero within minutes. Navigating a 330-meter-long tanker through a 3-kilometer channel without sight is a challenge captains must face. Radar becomes the only eye, yet even it can be disrupted in the storm. Hundreds of oil tankers operating simultaneously, burning low-grade heavy fuel, create a persistent haze over the strait. Combined with high humidity from the sea and desert sand, the air becomes dense and hazardous. It is one of the most polluted marine regions on the planet. A supertanker requires 3 to 5 kilometers to come to a full stop. In Hormuz's narrow 3-kilometer shipping lane, that means there is no margin for error. Captains must make split-second decisions, relying on years of experience and nerves of steel. A single collision could sink hundreds of millions of dollars and trigger a devastating oil spill in these confined waters. At the gateway of the strait, Hormuz Island appears like a work of art from above. Vivid red soil rich in iron oxide, interwoven with streaks of white, yellow, purple, and orange. It is known as the Rainbow Island. Beneath these extraordinary colors lies a history of thousands of years. when this region was once a global trade hub. The people of Hormuz do something few places in the world can claim. They eat the earth. This red soil, rich in iron oxide and minerals known as galak, is mixed into bread, used as a seasoning, or even eaten on its own. It is not poverty, but a unique culinary tradition deeply connected to the island's unusual geology. Every morning, fishermen set out to sea on small wooden boats, following traditions passed down for centuries. And every morning, they share the water with steel giants over 300 meters long, carrying oil for the global economy. Two worlds could not be more different, yet they coexist on the same narrow stretch of water. Bandar Abbas, a city of 500,000 on the northern shore, exists because of Hormuz and lives through it. Its port is Iran's main trade gateway, where goods from around the world arrive and Iranian oil flows out. For the people here, geopolitics is not abstract. It is their jobs, their income, and their daily lives. As the sun sets behind anchored oil tankers, Hormuz reveals a breathtaking beauty, red, orange, and purple blending across the calm sea. It is a moment where grandeur and fragility coexist. The pure beauty of nature, and beneath it, the ever-present tension of geopolitics. Saudi Arabia and the UAE have built pipelines across the desert to reduce dependence on Hormuz. But their total capacity can only handle about 20% of the required oil flow. The remaining 80% has no route except the strait. And building more pipelines? It would cost hundreds of billions of dollars, take decades, and face nearly insurmountable terrain challenges. In theory, tankers could reroute around the Cape of Good Hope in Africa. But that would add thousands of nautical miles, weeks of travel, and dramatically higher costs. Oil prices would rise 10 to 15% from transport alone, and the world would need twice as many tankers. It is not impossible, just too expensive to be practical. The world is transitioning toward renewable energy, but far more slowly than headlines suggest. Oil will still dominate global energy at least until the mid-21st century. During this transition, Hormuz remains irreplaceable. Dependency does not disappear overnight, it fades gradually over decades. Experts have modeled a scenario where Hormuz is closed for just 48 hours. Within the first 6 hours, global financial markets begin to tremble. By hour 24, oil prices could exceed $200 per barrel. By 48 hours, some Asian governments may convene emergency cabinets. No war is needed, just 2 days of closure. Globalization has created unprecedented prosperity, but it has also created critical vulnerabilities. Hormuz is the clearest example. A $100 trillion global economy depends on a narrow 33-kilometer strip of water. That is not strength, it is fragility dressed as prosperity. Every oil tanker that passes safely through Hormuz is the result of a delicate balance. between Iran and the United States, between Saudi Arabia and its neighbors, between geopolitical calculations and economic interests. Peace here is not luck. It is the product of constant restraint, day after day. And that restraint can break at any moment. Modern civilization is built on energy, and that energy must pass through Hormuz. We have created megacities, global supply chains, and complex transport networks, all relying on the uninterrupted flow through a strait narrower than a single city. It is one of the greatest contradictions of our time. Every morning, Hormuz awakens and continues its work, quiet, unseen, yet indispensable. As long as the world needs oil and economies remain interconnected, this strait will remain a crossroads of destinies. A narrow 33-kilometer strip of water, small on the map, yet carrying the weight of an entire civilization. The ocean covers more than 70% of Earth's surface, yet humanity has explored less than 20% of it. Beneath these silver waves lies a completely different universe, larger than any jungle or desert on land. Let us dive down into a world where darkness, pressure, and life exist under unimaginable rules. At just 10 meters below the surface, pressure has already doubled compared to land. At 200 meters, sunlight almost completely disappears, and the world turns into a cold blue-violet abyss. And far below that, thousands of meters in absolute darkness, life still continues. Coastal shallow waters are the busiest regions of the ocean, a city beneath the sea that never sleeps. Tropical coral reefs occupy only 1% of the ocean, yet they are home to more than 25% of all marine species. This is where our journey begins, before we descend into the darkness below. The ocean is divided into layers, each one a separate world with its own survival rules. The sunlight zone, from 0 to 200 meters, is where most familiar marine life exists. The deeper you descend, the colder it becomes, the greater the pressure, and the stranger the creatures you encounter. Before meeting the predators, look at the prey, millions of small fish moving like a single living organism. This phenomenon, known as a bait ball, is survival through unity. Every fish is trying not to be the one that gets caught. And surrounding this silver cloud, predators are waiting for the perfect moment to strike. This is the great white shark, a hunting machine refined through 400 million years of evolution. No giant brain, no complex strategy, only perfect instinct and a body engineered for killing. It can smell a single drop of blood in 100 liters of water and detect the electric fields produced by a prey's heartbeat from meters away. The great white's signature hunting technique is an ambush attack from below at speeds up to 40 kilometers per hour. It strikes seals with a devastating first bite, then retreats and waits for the prey to weaken from blood loss. Patient, precise, and ruthless, this is the hunting philosophy of an ocean ruler millions of years old. Hammerhead sharks may look strange, but their T-shaped heads are masterpieces of evolution. Electroreceptor cells spread across the wide surface allow them to detect prey hidden beneath the sand from far away. With eyes positioned on both sides, they gain nearly 360-degree vision. No blind spots, no escape. The tiger shark is the ocean's most terrifying omnivore. It will eat almost anything. Scientists have found car plates, tires, plastic containers, and even armor inside their stomachs. No standards, no limits, the tiger shark is both scavenger and predator at the same time. And then there is a species that is not only powerful but frighteningly intelligent. The orca, also known as the killer whale. They do not hunt alone. They plan, coordinate in groups, and teach hunting skills across generations. Orcas are the only marine species known to possess culture. Each pod has its own dialect, strategies, and traditions. Orca wave washing is a classic example of collective intelligence. The entire pod swims together to create artificial waves that knock prey off ice floes. They coordinate with military-like precision, each individual understanding its role in the hunt. No shark, no other marine predator can do this. This is the power of intelligence. Orcas live in matriarchal families where grandmothers hold the center of power. Male orcas almost never leave their mothers. They stay beside them for decades, often their entire lives. These family bonds are not just emotional, they are the foundation of survival and knowledge transfer. The blue whale is the largest creature ever to exist in Earth's 4 billion-year history, even larger than the dinosaurs. Its heart is the size of a car, and its heartbeat can be heard from 3 kilometers away underwater. One powerful blow from its lungs sends a 9-meter water column into the sky, enough to understand why ancient sailors believed in sea monsters. Despite being the largest animal on Earth, the blue whale feeds on some of the smallest creatures, tiny krill no larger than a finger. Every day it consumes nearly 4 tons of krill, filtering them through curtain-like baleen plates. This contrast, the greatest giant feeding on the smallest prey, is one of nature's most beautiful paradoxes. The humpback whale is the artist of the ocean, famous for songs that can continue for hours without stopping. Their complex melodies change with seasons and regions, traveling thousands of kilometers through the sea. No one fully understands the meaning of these songs. They remain one of the greatest mysteries on Earth. The humpback whale's bubble net technique is a remarkable hunting innovation. Whales swim in circles while releasing bubbles to create walls that trap fish. Then the group surges upward together with mouths wide open, swallowing tons of fish at once. This is not pure instinct. It is a learned skill passed down across generations, a true form of animal culture. From the ocean giants, let us turn to one of nature's smallest yet most extraordinary relationships, the clownfish and the sea anemone. The anemone protects the clownfish with its venomous tentacles, while the clownfish cleans parasites and brings oxygen to the anemone by fanning its fins. Perfect symbiosis, neither thrives without the other, a lesson in mutual dependence from nature itself. Sea turtles have crossed the oceans since the age when dinosaurs ruled the land, surviving for more than 100 million years. Yet the journey of every hatchling is one of the harshest survival battles in nature. Only 1 in 1,000 survives to adulthood. From beach to ocean, and back again to the very beach where they were born, it is the endless cycle of life. Under the moonlight, the mother turtle crawls ashore, to the very beach where she herself was born decades earlier, to lay her eggs. She cannot see well or hear clearly on land, yet she knows the exact location through Earth's magnetic field. After laying her eggs, she returns to the sea, never knowing whether her offspring will survive. Below 1,000 meters, no sunlight can reach. This is the midnight zone, a realm of eternal darkness. Yet darkness does not mean emptiness. More than 76% of creatures here can produce their own light. Bioluminescence is not merely beauty. It is language, deception, and signals of love in absolute darkness. The anglerfish uses light as a deadly trap. Curious prey swim toward the glowing lure and are instantly devoured. Females are dozens of times larger than males. The tiny male finds a female and permanently fuses himself to her body. It is one of nature's strangest love stories, where 2 bodies become a single living creature. The vampire squid may sound terrifying, but it is actually one of the gentlest creatures of the deep sea. It does not hunt. Instead, it feeds on drifting organic debris known as marine snow. Its enormous eyes, the largest relative to body size in the animal kingdom, collect every remaining photon of light in the darkness. At the deepest ocean floor, where sunlight never reaches and pressure crushes metal, hydrothermal vents create life from nothingness. Water heated to 400 degrees Celsius erupts without boiling because of immense pressure, surrounded by forests of tube worms, blind shrimp, and chemosynthetic bacteria. These creatures do not need sunlight. They survive on chemical energy from Earth itself, challenging everything we thought we knew about life. Tube worms can grow over 2 meters long and survive entirely without photosynthesis or ordinary oxygen. Symbiotic bacteria inside their bodies transform toxic sulfur into energy, creating an ecosystem powered by poison. If life can exist here, then it may exist anywhere in the universe, even beneath the icy moons of Jupiter. The Mariana Trench, the deepest point on Earth, plunges more than 11 kilometers deep, enough to bury Mount Everest with over 2 kilometers still above it. The pressure there equals the weight of 50 jet airplanes pressing on your body at once. Yet in 2012, scientists discovered living organisms at those depths, microbes, and even tiny worms. From the scorching abyss, our journey now reaches the opposite extreme, the Arctic Ocean, the coldest and loneliest realm of the global seas. Beneath meters of thick ice lies a silent but vibrant world where life has evolved to endure unimaginable cold. It is one of the planet's most fragile ecosystems and one of the fastest changing because of climate change. The beluga whale is known as the canary of the sea because of its astonishing range of sounds. They communicate through whistles, chirps, clicks, squeals, and calls, a vocal diversity second only to humans. Their flexible, rounded heads are unique among whales, allowing them to nod, turn, and move almost like humans. The narwhal, often called the unicorn of the sea, carries a spiral tusk that can grow up to 3 meters long, a highly specialized elongated tooth. Its tusk contains millions of nerve endings capable of detecting water temperature, salinity, and possibly even magnetic fields. Vikings once sold narwhal tusks across Europe for the price of gold, claiming they were magical unicorn horns. Polar bears are land animals, yet they depend entirely on sea ice for survival. They swim across vast distances between ice floes to hunt seals, their primary source of life-sustaining fat. But as the ice melts and the gaps grow wider, the great white bear is slowly losing the very ground beneath its feet. This is not a normal event of nature. It is a sign of a crisis unfolding in real time. The Arctic Ocean is losing its ice faster than at any point in the last 10,000 years. And every creature that depends on this frozen world, from narwhals to polar bears, now stands on the edge of disappearance. Coral reefs, the underwater cities supporting 1/4 of all marine life, are dying in silence. A temperature increase of just 1 to 2 degrees Celsius is enough for corals to expel their symbiotic algae, lose their color, and slowly starve to death. Since 1950, Earth has lost more than half of its coral reefs, a loss that may take centuries to recover, if ever. Every year, 8 million tons of plastic waste enter the ocean, equal to a garbage truck dumping trash every single minute. Sea turtles mistake plastic bags for jellyfish, their favorite prey, and die from intestinal blockage. By 2050, scientists predict plastic in the oceans could outweigh all fish combined, an almost unimaginable future. Overfishing has pushed more than 33% of global fish stocks beyond sustainable recovery. Bottom trawling destroys coral reefs and seafloors with the brutality of bulldozers, all to catch a single target species while devastating entire ecosystems. Millions of tons of unintended catch, dolphins, turtles, sharks, are thrown back into the sea dead, unnoticed and uncounted. Ocean acidification is one of the silent threats of our age. Excess atmospheric CO2 dissolves into seawater, turning it slightly acidic. Since the Industrial Revolution, ocean pH has dropped by 0.1, sounding small, but representing a 26% increase in acidity. Shells, corals, and calcium-based plankton are slowly dissolving. The very foundation of the marine food chain is beginning to collapse. In 2019, a dead blue whale washed ashore in the Philippines with 40 kilograms of plastic in its stomach. 40 kilograms of plastic bags, ropes, and foam packaging inside the largest creature ever to live on Earth. This was not an accident. It was the result of decades of humanity treating the ocean like a bottomless landfill. The future of the ocean does not depend on the strength of sharks, the intelligence of orcas, or the beauty of coral reefs. That future rests in the hands of a single species, the one that caused this crisis, and the only one capable of stopping it. Every choice we make today, From refusing a plastic bag, to skipping unsustainable seafood, to voting for climate action, determines whether these magnificent creatures will continue to exist. The ocean existed for 3.5 billion years before humans appeared. It survived 5 mass extinctions. Yet nothing has destroyed it as rapidly and deeply as what humanity has done in just 200 years of industrialization. The question is not whether the ocean needs us. The question is whether we are wise enough to save the very thing our own survival depends on. At the far end of Earth, a frozen continent waits in silence. 6 months of darkness are ending. The sun is returning. And with that light, life is preparing to explode. This is the Antarctic summer, the shortest and most intense season on Earth. The sun does not set for many continuous weeks. Every creature uses every precious hour of light. The Southern Ocean surrounds this continent like a vast ecological ring. Cold currents lift nutrients from the deep ocean to the surface. That is what creates one of the richest marine environments on Earth. As temperatures rise slightly, the sea ice begins to retreat. Millions of square kilometers of open water are released within weeks. This is the opening signal for a vast food chain. Sunlight penetrates the cold water and triggers an explosion of phytoplankton. They are too small for the human eye to see, yet their numbers reach into the trillions. They form the foundation that feeds the entire ocean. From space, the bloom looks like green clouds drifting beneath the sea. A single bloom can cover an area the size of an entire country. The Southern Ocean is breathing and awakening. Phytoplankton draws in krill, tiny creatures only a few centimeters long. Yet they appear in unimaginable numbers, reaching 500 million tons across the Southern Ocean. Krill is the heartbeat of this ecosystem. Each krill weighs less than 2 grams, no bigger than a child's little finger. Yet they gather in swarms so dense they can redden entire stretches of sea. Without krill, Antarctica would become an ocean desert. Krill swarms migrate vertically each day, rising to feed on algae at night and descending to escape predators by day. This journey is repeated millions of times every hour. They are among the greatest biological forces on Earth. They come from thousands of kilometers away, the largest animals ever to live on this planet. Blue whales can weigh more than 150 tons and stretch longer than 2 buses placed end to end. Antarctica is the feast they cross oceans to reach. Each day, an adult blue whale can swallow up to 40 million krill. Its mouth opens like a cavern, straining water through thick baleen plates. It is one of the most efficient feeding systems in the animal kingdom. This natural filter evolved over 30 million years. No teeth, no chewing, only filtering and swallowing. With every gulp, millions of tiny lives disappear. Humpback whales arrive in Antarctica with a remarkable hunting secret. They cooperate in groups, rare for animals that often live apart. Each individual takes a separate role in the encircling attack. Bubblenet feeding is one of nature's most complex hunting behaviors. A lead whale circles beneath the swarm, blowing bubbles to build a wall of air. Krill panic and bunch together, and that is when the whales strike. The final strike happens in less than 2 seconds. Yet each surge upward captures thousands of krill. This perfect coordination is the collective intelligence of whales. Those long white fins resemble wings of a creature flying underwater. Humpback whales are among the farthest migrating marine mammals, traveling up to 8,000 kilometers each way. Antarctica is the final destination in their search for life. An Adelie penguin colony can hold 500,000 birds. They return to the same rocky nesting grounds year after year. Their calls rise like a city waking to life. Male Adelies offer pebbles to mates as a form of courtship. A pebble nest keeps eggs above the cold, wet ground. Every stone is valuable property, and sometimes stolen from neighboring nests. Underwater, penguins transform completely, no longer clumsy on land. They can swim at 25 kilometers per hour and dive to 150 meters. Wings no longer used for flight become perfect paddles of the sea. The chinstrap penguin is named for the black line beneath its chin like a helmet strap. They are among the noisiest Antarctic penguins. Their colonies can reach millions, strange megacities of birds. Penguin feathers are waterproof, trapping air like thermal armor. Water at -2 degrees Celsius cannot penetrate this natural defense. Beneath the surface, they move like black and white bullets. The emperor penguin is the largest penguin, nearly 1.2 meters tall and weighing up to 40 kilograms. Its orange-yellow chest and neck markings are unmistakable. It is a living symbol of endurance in extreme conditions. Emperor chicks hatch in the brutal winter, not in summer. They are kept warm on their father's feet through the first months of life. Outside may be -60 degrees Celsius, while inside the brood pouch it is +36. Once large enough, emperor chicks gather into nursery groups called creches to stay warm together. Parents return from the sea and identify their own chick by its unique call. Each chick has a voice print as distinct as a fingerprint. The leopard seal is one of Antarctica's apex predators, weighing up to 500 kilograms. Its name comes from the dark spots scattered across its silver-gray coat. Beneath the ice, it waits like a living trap. The moment a penguin enters the water, the leopard seal strikes. Its reaction is faster than the blink of an eye, reaching speeds of 40 kilometers per hour. Its success rate during pursuit is remarkably high. Despite the name, the crab-eater seal does not eat crabs. It feeds on krill and is among the greatest krill consumers in the ocean. Its teeth evolved into a perfect filtering tool, like miniature whale baleen. When the crab-eater closes its jaws, water escapes while krill remain trapped inside. It is one of the strangest dental structures in the animal kingdom. Independent evolution created a solution similar to whales, but in its own way. The Weddell seal can hold its breath for 80 minutes and dive 600 meters deep. It uses its teeth to maintain breathing holes in the ice throughout winter. It is one of the southernmost marine mammals living year-round near Antarctica. The wandering albatross can travel thousands of kilometers without landing. It harvests the wind, rising and falling in long glides, turning storms into energy. The Southern Ocean, with its fierce winds, is paradise for this bird. As the sun begins to set, it will not rise again for many months. Temperatures fall below -40 degrees Celsius, with winds reaching 200 kilometers per hour. Antarctica enters winter, the harshest long night on Earth. In winter, sea ice expands by another 19 million square kilometers each year. That is nearly twice the size of the Antarctic continent itself. It is one of the greatest physical transformations on the planet. In blizzards, male emperor penguins incubate eggs with no food. They rotate slowly through the crowd so every bird gets a turn in the warm center. This behavior is not taught. It is an instinct shaped by millions of years of evolution. In the darkness of winter, the sky answers with the southern lights. These dancing ribbons are charged particles from the sun colliding with the atmosphere. For penguins below, it is the only light in the long night. Beneath the ice, the world is entirely different from the frozen surface above. Water remains near -1.8 degrees Celsius, cold but survivable. Weddell seals move through this realm as if inside a vast cathedral of ice. Life does not stop in winter, it simply moves deeper. On the Antarctic seafloor, vividly colored creatures survive at -2 degrees Celsius. Evolution here is slow, yet stranger and more unique than anywhere else. During the 65 days of incubation, the male eats nothing at all. He survives on stored fat, losing several kilograms each week. It is the longest fasting feat of any bird on Earth. The Larsen Sea ice shelf fractured in 2017, releasing an iceberg larger than Belgium. Antarctic temperatures are rising 3 times faster than the global average. What took thousands of years to form is now disappearing within decades. The sound of collapsing ice shelves can travel for tens of kilometers. Each event may raise global sea levels by a few millimeters. Small numbers, but together they build into disaster for millions of people. Many Adelie penguin colonies on the Antarctic Peninsula have declined by up to 70%. Ice melts faster than they can adapt, flooding nests before eggs hatch. The food web is also disrupted as krill decline with weakening phytoplankton blooms. Commercial harvesting of krill has risen sharply over recent decades. Krill is used for animal feed and omega-3 extraction. But removing too much krill means removing the foundation of the entire ecosystem. Whales grow thinner as krill supplies decline, with body fat reserves dropping sharply compared with 20 years ago. They must travel farther and spend more energy to feed. Blue whales once came close to extinction, and that danger has never fully disappeared. Scientists drill deep into Antarctic ice to read 800,000 years of climate history. Each layer preserves the memory of an ancient atmosphere. And for the first time in that entire record, CO2 has risen beyond 420 ppm. Antarctica has warmed by 3 degrees Celsius since the 1950s. A small number, yet for this fragile ecosystem it marks the difference between survival and disappearance. A tipping point is approaching, and no one knows exactly when it will be crossed. These eyes know nothing of emissions or policy. They know only the need for food, warmth, and a patch of ice to stand on. Yet even these simple needs are threatened by choices made on the other side of Earth. Blue whales were hunted to the edge of extinction, with 99% of their population killed in the 20th century. Then humanity stopped, and they began to recover. It is proof that nature can heal when given the chance. In 2016, 24 nations agreed to create the world's largest marine protected area in Antarctica. More than 1.5 million square kilometers were shielded from commercial fishing. It remains one of humanity's greatest conservation victories. Krill are tiny, yet they help the whole planet breathe. Through photosynthesis and the food web, the Southern Ocean absorbs nearly 40% of global CO2. Protecting krill means protecting our own climate system. Antarctica does not need humanity to survive. But humanity needs Antarctica to regulate climate, stabilize sea levels, and preserve biodiversity. We and this frozen continent are bound together. The sun will set and winter will return. But the real question is this: when the sun rises next year, will the world below still be the same? Antarctica's future is not written here, it is written by the choices we make today.
You look at the ocean's surface and think you are seeing the Atlantic, But that surface is only a curtain, a thin sheet of glass separating our world from an entirely different one below. "99% of this ocean's volume exists where there is no light, no warmth, no familiar sound, and yet it is still full of life."
With every meter you descend, something changes. Light weakens, colors disappear in sequence. Red first, then orange, yellow, green. Only blue remains. Then violet. Then nothing. Darkness does not arrive from one direction. It comes from everywhere at once, slowly and completely consuming everything.
Before we descend deeper, look at the smallest life in the upper layer, phytoplankton. Single-celled organisms invisible to the naked eye produce more than 50% of the oxygen in Earth's atmosphere. Not rainforests, not the Amazon. These microscopic drifters, suspended in the top 200 meters of the Atlantic, are what keep you breathing.
This is a bait ball. Millions of herrings gather into a dense sphere and move as if they were a single organism. No leader, no central command. Each fish reacts only to its nearest neighbor, and from millions of simple decisions emerges a collective intelligence powerful enough to deceive sharks and tuna for hours.
Funnus finis, the Atlantic bluefin tuna. 3 meters long, weighing over 600 kilograms, capable of bursts up to 70 kilometers per hour. They are warm-blooded, rare among fish, maintaining a body temperature higher than the surrounding water to maximize muscle performance. Each year they migrate from the Caribbean to Norway and back, tens of thousands of kilometers with no maps, no GPS, guided only by Earth's magnetic field.
Dolphins are not just intelligent, they have names. Each dolphin produces a unique signature whistle, like an acoustic fingerprint, and others in the pod call them by it. They remember companions after years apart. They teach their young hunting techniques through demonstration. The Atlantic is home to minds like these, right at the surface, right before our eyes.
Dermacheles coriacea, the leatherback turtle, the largest living reptile, weighing up to 900 kilograms. They dive deeper than 1,200 meters to hunt jellyfish, prey they pursue across the Atlantic. This species has existed for 100 million years, surviving the extinction that wiped out the dinosaurs. And now, they face the greatest threat in their history, us.
Cyanea capillata, the lion's mane jellyfish. One of the longest animals ever recorded, its tentacles stretching up to 37 meters, longer than a blue whale. No brain, no heart, no blood. A body made of 95% water. And yet, it hunts, reproduces, and has existed for 500 million years, long before fish first appeared on Earth.
The Sargasso Sea is the only sea on Earth without a shoreline, its boundaries defined by 4 surrounding currents. The floating mats of golden sargassum form a complete ecosystem. Hundreds of species cling to it, hide within it, feed upon one another, entirely dependent on this drifting forest. It is also where European eels travel over 6,000 kilometers to spawn, and then die.
200 meters. Sunlight officially ends here. Above is the world you know. Below is a world humanity has only just begun to glimpse. More than 80% of the ocean floor has never been directly observed. What we are about to enter, much of it is being told for the first time. Let's keep descending.
The mesopelagic layer, also known as the twilight zone, stretches from 200 to 1,000 meters. This is a realm of perpetual dusk, where day and night lose their meaning, and light becomes only a faint memory from above. Few people realize this zone holds the largest animal biomass on the planet, more than all surface fish combined, yet we know almost nothing about it.
Myctophody, lanternfish. These tiny fish, only a few centimeters long, may be the most abundant fish on Earth by total biomass. Each night, they rise to the surface to feed. Each morning, they descend into darkness to avoid predators. This vertical journey of hundreds of meters, repeated every 24 hours, is the largest migration on the planet, and almost no one knows it exists.
A siphonophore is not a single organism, but a colony. Thousands of tiny individuals called zooids are linked together. Each evolved to specialize in a single task: hunting, digestion, reproduction, propulsion. None can survive alone. It represents one of the most blurred boundaries between individual and collective in the natural world, and some species grow up to 50 meters long.
Vampiroteuthis infernalis, the vampire squid from hell, a scientific name that lives up to its meaning. Neither true octopus nor true squid, it is the last surviving member of an ancient evolutionary lineage. When threatened, it turns itself inside out like a cloak, exposing sharp spines, and releases not black ink, but clouds of bioluminescent light, turning darkness into illumination.
Humboldt squid communicate by changing the color of their skin. Millions of chromatophores expand and contract in an instant, producing complex flashing signals we have yet to decode. They hunt cooperatively, coordinating attacks without sound, using only light. It is a complete language, written on skin, read by sight, in total darkness.
Regalachus glesnae, the oarfish. Reaching up to 11 meters, it is the longest bony fish on Earth. For centuries, oarfish appearing near shore were believed to signal earthquakes and tsunamis, not entirely without basis, as they inhabit tectonic fault zones. They were never filmed alive in their natural habitat until 2001. Before that, we only knew them from bodies washed ashore.
Marine snow. The remains of phytoplankton, animal waste, mineral shells of microorganisms all clump into tiny particles and fall continuously from the surface. It is the only food supply for life below the light zone. But marine snow is also a carbon pathway, carrying atmospheric CO2 to the ocean floor. The Atlantic is absorbing humanity's carbon and burying it for thousands of years. Every second, every day.
Isurus oxyrhynchus, the short-fin mako shark, the fastest shark in the ocean, reaching 70 kilometers per hour and leaping up to 6 meters above the surface. Like the bluefin tuna, makos are warm-blooded, maintaining elevated body temperatures to maximize muscle and brain performance while hunting. They can detect prey movement through electroreceptors across their snouts.
Every night at sunset, an extraordinary event unfolds across the global ocean. Billions of organisms, lanternfish, shrimp, small squid, copepods, rise from the depths to feed at the surface, then descend before dawn. This vertical migration moves vast amounts of carbon from surface waters to the deep ocean each night, one of the most important mechanisms regulating Earth's climate, and we are only beginning to understand it.
Copepods, smaller than a grain of rice, may be the most numerous animals on Earth. Trillions are drifting in the Atlantic right now. They are the central link in the entire marine food web, feeding on phytoplankton, eaten by small fish, and ultimately sustaining whales. If copepods disappeared, the ocean ecosystem would collapse within weeks.
Architeuthis ducks, the giant squid, growing up to 13 meters long with the largest eyes in the animal kingdom, 27 centimeters wide, the size of a dinner plate, designed to capture the faintest photons in the darkness. For centuries they were legend, the Viking kraken, the sailor's sea monster. Not until 2004 were they first photographed alive in their natural habitat, and much about them remains unknown.
During World War II, the U.S. Navy discovered something strange. Sonar repeatedly misread the ocean floor. They called it the false bottom. Later, scientists realized it was the deep scattering layer, a dense concentration of organisms reflecting sound waves like solid ground. Billions of creatures gathered at the edge of light, forming a biological layer so thick, sonar mistook it for rock. War had accidentally uncovered one of the greatest ecological phenomena of the ocean.
"1,000 meters. Sunlight does not exist here. Not a single photon from the sun reaches this layer. Temperature, 4 degrees Celsius. Pressure, 100 atmospheres, 100 times surface pressure. This is the bathypelagic zone, the realm of true darkness, stretching from 1,000 to 4,000 meters, and it holds more mysteries than everything we have discovered above."
Melanocetus johnsoni, the black anglerfish. The female carries a biological lure on her head, its tip filled with bioluminescent bacteria, the only trap she needs. Prey approaches out of curiosity or mistake and disappears into elastic jaws capable of swallowing something twice her size. Her stomach can expand almost endlessly. In this darkness, you never know when the next meal will come.
Male anglerfish are up to 60 times smaller than females. When he encounters a female, he bites into her skin and begins to fuse, circulatory, nervous, and digestive systems gradually connecting before dissolving. Eventually, the male is no longer an independent individual. He becomes an appendage of the female, existing only to provide sperm. This is one of the most extreme forms of biological integration in nature.
Dragonfish possess a weapon no prey here is prepared for: infrared light. Most deep-sea creatures cannot see infrared because evolution never created sensors for something absent from their environment. Dragonfish use it as a stealth flashlight, illuminating prey without the prey knowing it is being lit.
They truly see in the darkness, while everything around them remains blind. Macropinna microstoma, the bear eye fish. Its head is completely transparent, like a diving helmet, allowing its tubular eyes to rotate freely inside, looking upward to detect faint backlit prey silhouettes, then rotating forward to strike. We did not know this until 2004, because bringing them to the surface shattered the transparent dome. For decades, we described the species incorrectly. Chaliotis sloani, the viperfish. Fangs so long it cannot close its mouth, curving outward to form an inescapable trap. Along its belly, photophores emit light matching the faint glow from above, allowing it to disappear when viewed from below. In this darkness, even darkness itself becomes a weapon. Grimpeteuthis, the Dumbo octopus, lives between 1,000 and 7,000 meters, the deepest living octopus known. Its body is nearly transparent, lacking an ink sock because concealment is unnecessary where there is no light. They do not follow seasonal reproductive cycles like surface species. Females carry eggs and can lay them year-round when conditions allow. In eternal darkness, time operates differently. Himantolophus, the deep-sea football fish. Its round body is an adaptation, no streamlined scales for speed, because speed does not matter here, energy conservation does. It barely swims, hovering and waiting. Its lure emits silver light, different from the common blue, attracting prey accustomed to blue glows. In the darkness, even the color of light is strategy. In absolute darkness, some species evolved in the opposite direction. Instead of dark camouflage, they became transparent. There is nothing to see as light passes through like air. This is the most perfect invisibility possible, not by blending into the background, but by erasing one's shadow entirely in a world without light. Mantis shrimp can strike with acceleration faster than a bullet, 23 meters per second in under 3 milliseconds. The punch creates cavitation bubbles, low pressure bubbles that collapse at temperatures as hot as the surface of the sun for a fraction of a second. Even if the direct hit misses, the shockwave can kill the prey. They carry a miniature nuclear-level physical weapon in their claws. Deep-sea hatchetfish practice camouflage known as counter-illumination. Their bellies glow through photophores at precisely the same intensity as the faint light from above. Viewed from below, they vanish into the background and cast no shadow. Predators see nothing. It is optical stealth technology, perfect, battery-free, evolved over millions of years. Acanthostir plancy, the crown of thorns starfish. Not a deep-sea species, but a perfect example of how one species can destroy an entire ecosystem. Each individual consumes coral. During outbreaks, they blanket and eliminate entire reefs in months. Ecosystems built over centuries erased in a single season. And outbreaks are becoming more frequent as oceans warm. Samniosis microphocephalus, the Greenland shark, the longest living vertebrate known on Earth. Radiocarbon analysis of islands tissue suggests one individual lived over 400 years, born before Galileo invented the telescope.
They grow so slowly, they reach sexual maturity only at 150 years. In 2 degrees Celsius water, time literally moves slower. Sperm whales dive to 2,000 meters and can hold their breath for over 90 minutes. In total darkness, they hunt giant squid using echolocation, producing the loudest clicks in the animal kingdom, 230 decibels, powerful enough to stun or kill prey before contact. Many sperm whales bear large circular scars, marks left by giant squid tentacles in battles no human has ever witnessed. Stillness is the most effective hunting strategy in darkness. Many species here never actively chase prey. They wait, day after day, month after month, hovering or lying motionless, consuming minimal energy. When prey comes close enough, in an instant. Where food is scarce and energy more precious than gold, patience is not a virtue, it is survival. 4,000 meters. The seafloor, not rock, but mud. Fine sediment tens of meters thick, accumulated from marine snow over millions of years. This is the abyssal plain, the flattest and most extensive terrain on Earth, stretching thousands of kilometers unchanged, silent, dark, and cold. And still, life exists here, though no one knows exactly what kind or how much. 3,800 meters beneath the Atlantic, 700 kilometers from Newfoundland. RMS Titanic has rested here since the night of April 15, 1912. But this is no longer just a wreck. It is a complete ecosystem. Coral clings to the railings, fish move through corridors once filled with people. Octopus inhabit rooms that were once first-class cabins. Halomonas titanica, bacteria named after the ship itself, are consuming Titanic from within. They feed on iron, excreting intricate rust formations called rusticles, up to 90 centimeters long, housing entire microbial communities inside. Scientists estimate Titanic may fully collapse within the next 30 years. The ship is being slowly digested by millions of invisible organisms. In 1912, this was the most luxurious ship ever built. Crystal fountains, grand staircases, private refrigeration for each cabin. Now, nothing remains. Wood consumed by bacteria, carpets and curtains dissolved, only metal and mud endure. Yet within that mud, thousands of objects remain intact. Leather shoes, wine bottles still holding wine, silverware still gleaming in ROV light after more than a century. From the 15th to 18th centuries, hundreds of Spanish galleons carried gold and silver from the Americas to Europe, and many never arrived. Storms, reefs, pirates, the Atlantic took its share. Billions in treasure may still lie undiscovered in these wrecks. Yet more valuable now, they have become coral reefs, habitats for hundreds of species that could not survive without them. The U.S. East Coast from Florida to Cape Hatteras. Sailors in World War II called it Torpedo Junction. German U-boats hunted here from 1942, sinking hundreds of ships within months, sometimes within sight of shore. Now the wrecks of U-boats and Allied vessels lie side by side beneath the sea, coral covering both, hostility dissolved in time. SS Thistlegorm, A British military supply ship bombed in 1941 sank with its cargo intact. Trucks, motorcycles, rifles, boots, boxed watches. Today, everything remains as it was loaded, neatly arranged yet covered in coral and anemones. Fish swim through motorcycles like a forest. War created a sanctuary. Henrietta Marie, a British slave ship wrecked in 1700 off Florida. When divers found it in 1972, they discovered hundreds of iron shackles scattered across the seabed. An estimated 200 Africans were chained in its hold when it sank. This wreck stands as physical evidence of one of humanity's darkest chapters, resting silently beneath the Atlantic for 3 centuries. Not only ships, the Atlantic is also a graveyard for thousands of aircraft. B-17 bombers flying from America to Britain often ran out of fuel and ditched at sea. Crews were rescued, the planes were not. Now these flying fortresses lie on the seabed like rusted steel monuments, cockpits intact, tail guns still facing backward, waiting for enemies that will never come again. In 1968, the U.S. nuclear submarine USS Scorpion disappeared en route from the Mediterranean to Norfolk. 99 sailors never returned. It was found that same year at 3,000 meters, shattered into pieces. The official cause remains unresolved after more than 50 years. The Atlantic keeps its secrets. The most remarkable thing about these wrecks is not that they sank, but what happened afterward. Hard metal in soft sediment is a rare resource, an anchor point for coral, anemones, mussels, oysters. When coral grows, fish arrive. When fish arrive, larger fish follow. Within decades, a wreck becomes one of the most biodiverse sites in surrounding waters. Human tragedy becomes nature's sanctuary. Modern technology is transforming how we approach these graveyards. ROVs can descend to 6,000 meters, film in high resolution, collect samples without touch. Wrecks once unreachable are now mapped in full 3D by sonar. Yet for every wreck discovered, hundreds remain unknown, lying silently in darkness, waiting. An estimated 3 million shipwrecks lie on the ocean floors, most within the Atlantic. Each wreck is a story interrupted, a journey never completed. Yet, from another perspective, the Atlantic has preserved over 3 million physical records of human history under near-perfect conditions. The ocean does not only take, it also keeps. In the oxygen-poor mud of the Atlantic seabed, ordinary decay bacteria cannot function. Many organic materials are preserved almost perfectly. Leather shoes from Titanic still hold their shape after more than a century. Leather, fabric, wood would normally vanish, but here, time moves slower. Decay proceeds differently. The deep seafloor is the most perfect archive on the planet.
The oldest wrecks in Atlantic-adjacent waters, Greek, Roman, Phoenician amphorae, remain intact after 2,000 years. Inside some amphorae, Traces of wine, olive oil, honey still remain. Goods packed by hands turned to ash millennia ago. The Atlantic is a library.
Underwater archaeology is among the most difficult sciences. No true gravity, limited visibility, pressure increasing with every meter, dive time restricted, and the subject of study constantly decaying, looted, or accidentally damaged. Each expedition is a race against time to preserve evidence before the Atlantic claims it forever.
The final stage of every wreck, when coral has fully covered it, when metal has dissolved into sediment, when no artificial trace remains visible, is complete integration into nature. Ship becomes rock, rock becomes reef, reef becomes ecosystem. Humanity builds, the Atlantic transforms, nature completes. The cycle has no end.
If you drained the entire Atlantic Ocean, the first thing you would see is a mountain range. The Mid-Atlantic Ridge, stretching 16,000 kilometers, is the longest mountain chain on Earth. Most of it lies underwater, except Iceland, the only country on Earth built directly atop a mid-ocean ridge. At the center of the ridge lies a rift valley, a fracture where two tectonic plates are pulling apart. Speed, about 2.5 centimeters per year, the rate your fingernails grow. It sounds small, but over 100 million years, that is why the Americas and Africa are now 7,000 kilometers apart. The Atlantic is growing, every day, millimeter by millimeter. When magma erupts from the rift and meets 2 degrees seawater, it instantly solidifies into rounded formations called pillow lava. Billions of tons of new rock are created each year from Earth's interior, filling the gap between separating plates. The Mid-Atlantic Ridge is a factory of ocean floor, operating continuously for 200 million years without a single day of rest. Iceland is the only place on Earth where you can stand between 2 tectonic plates and see them with your own eyes. The Thingvellir Valley, an exposed rift, widens by 2.5 centimeters each year. Divers can swim between the North American and Eurasian plates, touching both at once. It is the only place in the world where you can physically touch the force creating the Atlantic. Scattered along the ridge and across the Atlantic are more than 800 identified seamounts, underwater volcanoes not tall enough to break the surface. Each is a biological oasis. Currents striking the slopes push nutrients upward, creating massive feeding grounds. Whales migrate along these seamount chains like following a food map. Cold water corals cling to basalt rock, building living structures without sunlight. Lophelia pertusa, cold water coral. It needs no sunlight, no warm temperatures. It survives at depths from 40 to 3,000 meters and waters 4 to 13 degrees Celsius. Atlantic cold water reefs can rise 35 meters high and stretch for kilometers, thousands of years old. They grow only millimeters per year. A 1-meter structure may be 1,000 years old. And we have destroyed more cold water reefs than we have ever discovered. Beneath the Rift Valley, magma lies only a few kilometers below the seafloor. Heat from Earth's interior seeps through rock, heating seawater that infiltrates cracks, returning it superheated through hydrothermal vents. This is a massive heat circulation system, cold water in, hot mineral-rich water out, continuous for millions of years, sustaining ecosystems without sunlight. The Mid-Atlantic Ridge is one of the most seismically active regions on Earth. Thousands of small quakes each year, most unfelt at the surface. But when tectonic plates shift suddenly, shock waves travel through seawater at the speed of sound, 1,500 meters per second. Large quakes here can trigger tsunamis reaching the coasts of Europe and the Americas. The Atlantic seafloor is Earth's most perfect geological book. The farther from the ridge, the older the crust, each layer recording a chapter of geological time. By reading the Atlantic floor, geologists reconstructed 200 million years of continental drift, from the breakup of Pangaea to the present. Scattered along the Mid-Atlantic Ridge are islands, volcanic peaks tall enough to breach the surface. Ascension, St. Helena, Tristan da Cunha, among the loneliest islands on Earth, thousands of kilometers from the nearest continent. St. Helena, Napoleon's place of exile, rises 4,000 meters from the seafloor, yet only 818 meters above sea level. When magma solidifies into rock, magnetic minerals align with Earth's magnetic field, recording its direction like magnetic tape. Earth's magnetic field reverses every 200,000 to 300,000 years, and each reversal is preserved in alternating magnetic stripes on the seafloor. By reading these stripes, we know precisely how the ocean floor has spread, the most perfect evidence of plate tectonics. 2,000 meters beneath the Atlantic surface, surrounding water temperature 2 degrees Celsius. And from this fracture, water erupts at 400 degrees Celsius. It does not boil, because 250 atmospheres of pressure keep it in a supercritical liquid state. This is a hydrothermal vent, and surrounding it is a complete ecosystem that survives without a single photon of sunlight. Black smokers are mineral chimneys formed when superheated, mineral-rich water meets cold seawater. They can rise up to 60 meters, grow within decades, and sometimes collapse within hours. The fluid they release is rich in hydrogen sulfide, methane, and metals, toxic to most life on Earth. Yet here, specialized organisms have evolved to turn poison into energy. Riftia pachyptilla, giant tube worms, have no mouth, no stomach, no digestive system. They survive entirely through chemosynthetic bacteria living in a special organ called the trophosome, which can make up 15% of their body weight. These bacteria convert toxic hydrogen sulfide into organic energy. This was the first compelling evidence that life does not require sunlight to exist. Rimicaris exoculata, blind vent shrimp, have completely lost their eyes through evolution. In their place, they possess a primitive light-sensitive organ on their backs, capable of detecting faint infrared radiation from the vent, enough to navigate. Densities can reach 2,500 individuals per square meter, almost unimaginable. Kiwa hirsuta, the yeti crab, The dense white hairs on its claws and chest are not for warmth. They are bacterial gardens. The crab cultivates chemosynthetic bacteria and harvests them as food. This is agriculture, farming and harvesting at 2,400 meters below sea level in near boiling water. Evolution invented agriculture millions of years before humans. Chrysomalin squamiferum, the scaly-foot snail, is the only known animal with an exoskeleton made of iron sulfide. Its shell and scales are mineralized directly from vent fluids. When discovered in 2001, the US military studied its shell structure for advanced armor design. Sometimes the best solutions are waiting on the ocean floor. In 2000, scientists discovered the lost city on the Mid-Atlantic Ridge, a vent system unlike black smokers. Instead of acidic, superheating water, it emits warm alkaline fluids, 40 to 90 degrees Celsius, forming white towers up to 60 meters tall, made of aragonite and calcite. Lost City has been active for at least 30,000 years. The chemical reactions here produce hydrogen and methane, the most fundamental molecules of life. Archaea, ancient microorganisms, live in vent waters exceeding boiling temperature. Pyrolobus fumari survives at 121 degrees Celsius, the temperature of laboratory sterilization autoclaves. These are among the most extreme life forms known, and may be direct descendants of Earth's earliest organisms 3.8 billion years ago, when the planet resembled this hellscape. Pycnogonids, sea spiders, are not true spiders, but a distinct class of arthropods. In deep, cold waters and vent regions, some species reach giant sizes, legs up to 70 centimeters long. This is deep-sea gigantism. Cold temperatures and high oxygen levels allow invertebrates to grow beyond surface limits. Here, the rules of size are rewritten. Bathymodialis, giant vent mussels, host chemosynthetic bacteria in their gills instead of filter feeding like typical mussels. They are mobile chemical factories. Some species can survive in both methane-rich and hydrogen sulfide-rich environments, earning the nickname dual fuel. In unstable vent habitats, flexibility is survival. Hydrothermal vents do not last forever. When magma shifts or cools, the heat source shuts down, sometimes within days, sometimes within hours. The ecosystem depending on that vent begins to die. But before it does, larvae and spores disperse into deep currents, the offspring of a dying vent drifting in search of another, perhaps hundreds of kilometers away. Cold seeps are not hot vents, but slow leaks of methane and hydrogen sulfide without heat. No towers, no smoke, only bubbles rising and white bacterial mats spreading like snow. Cold seep ecosystems are less rich than hydrothermal vents, but far more stable, lasting hundreds of thousands of years, sustaining unknown communities awaiting discovery. DSV Alvin, the legendary American research submersible, first brought humans to observe hydrothermal vents in 1977. When the crew saw forests of red tube worms in total darkness, they could hardly believe their eyes. It is said a biologist opened a bottle of wine kept for special occasions right then and there. This was one of the most important biological discoveries of the 20th century, and it happened on the ocean floor. Megaptera novae angliae, the humpback whale, 16 meters long, weighing 36 tons. They breach, launching their entire bodies out of the ocean, and no one knows for certain why. Some theories suggest parasite removal, others social communication, others play. Perhaps all are true. In the Atlantic, humpbacks migrate annually from the tropical Caribbean to the far north, one of the longest migrations of any. Male whales sing, and their songs have structure. Themes, repetition, variation, like jazz. Songs evolve seasonally and yearly, spreading through social learning. A melody born in the Caribbean can appear years later off Hawaii. This is oral culture, no writing, no schools, carried across entire oceans. Balanoptera musculus, the blue whale, is the largest creature to ever exist in Earth's history. Larger than any dinosaur, its heart weighs 600 kilograms, large enough for a human to crawl through its aorta. Its call, 188 decibels, is the loudest sound in the animal kingdom and can travel thousands of kilometers underwater. In just 1 century, we nearly drove the greatest animal on Earth to extinction.
Carcharodon carcharias, the great white shark. In the Atlantic, they do not stay in one place. Tagged individuals have swum from the U.S. East Coast across the ocean to Africa and back, over 20,000 kilometers in a year. Why? Still uncertain. Great whites have existed for 16 million years, long before humans, and we still do not fully understand their migrations.
Siphius gladius, the swordfish, capable of bursts up to 100 kilometers per hour. They do not stab prey with their bill. They slash through schools of fish, then circle back to consume the injured. They possess specialized organs that warm their eyes and brain, raising eye temperature 10 to 15 degrees Celsius above surrounding water, enhancing visual processing in cold, deep nighttime hunts. Manta birostris, the oceanic manta ray, wingspans up to 7 meters, weighing 2 tons. They migrate across the Atlantic following plankton blooms and temperature gradients. They have one of the largest brain-to-body ratios among fish and pass multiple cognitive tests. Mantas recognize themselves in mirrors, one of the few non-primate species known to do so. We still do not know exactly how long they live. Anguilla anguilla, the European eel. It lives 10 to 20 years in European rivers and lakes. Then something changes. Eyes enlarge, the body turns silver, digestion shuts down. They swim 6,000 kilometers to the Sargasso Sea to spawn and die. Their young drift for 3 years on the Gulf Stream back to Europe. The life cycle is complete, yet no one has ever witnessed European eels spawning. A mystery unfolding for millions of years without human observation. Each autumn, billions of herring migrate south along the Atlantic coast. Their schools are so dense that ship sonar mistakes them for the seabed. Whales, tuna, sharks, seabirds all converge for what may be the greatest feeding event on Earth. And when it ends, the herring continue, billions of small creatures coordinating 1,000-mile journeys through simple rules.
Octopus vulgaris, the common octopus, is among the most intelligent invertebrates on Earth. They solve puzzles, use tools, recognize human faces, and treat individuals differently. Each arm contains its own semi-autonomous nervous system. 2/3 of neurons are in the arms, not the brain. Even a severed arm can respond independently for up to an hour. The octopus thinks with its body.
Hippocampus, the seahorse. Males become pregnant. They possess brood pouches, receive eggs from females, nourish